Dear students and friends, today we are going to introduce or study electrical circuits and network analysis. Why I named this subject as like this is, for EEE it's called electrical subject, electrical circuits. For ECE it is called network analysis. Whatever the name it is, the both content is same. But the subject is so important because it is linked to electrical engineering in other subjects. Like for example, in power systems, you cannot study without two-port parameters. And in electronic circuits, you cannot study without KVL and KCL and networks. So therefore, this subject has a link to so many other subjects in the coming higher level, whether it is in GATE or competitive exams, even in BTech. This became the first and foremost subject for EEE and ECE and instrumentation for all these three branches. And if you know how to analyze electrical circuits, then only we can analyze electronic circuits. For example, if you study the time response of electrical circuit, you can easily understand pulse digital circuits, that's called PDC. So without electrical circuits and time response or transients, you can never study PDC. So if you don't understand this, that pulse circuits you can never understand. Similarly, if you don't understand the sinusoidal analysis in networks, you cannot study analog circuits in higher level. So that's a link between these two, and as I said, in two ports also you have in power systems. And this subject also has a continuity to control systems. So whenever people want to have a system to analyze, whether it is a control system or a signal system, people generally take electrical circuit as a system, as an example to illustrate what is really happening, how the exact values are coming. With that way, if you are really good in this subject, you can as well cope up at least 5 subjects in your respective branch. 5 subjects means ADC, analog circuits, pulse circuits. Even in communication system, you have all these links when we go ahead. Similarly, for EEE students, control system has a link, then power system has a link, even machines to explain when you draw the equivalent circuits for any system, including motorbike, you will have electrical circuit. So whatever the system that we are studying, electrical equivalent comes into networks. That's why any subject will be brought into this subject and then be analyzed. That's why this big subject became a very serious and very important and a foundational course for all other subjects of engineering. That's why most of the students, if they fail in this subject, they definitely will fail in all other subjects. So we will really see why it is important, how it is linking, and what are the different things in this particular subject, and what books to study also we will see, and then link in the higher level in other subjects. All these lectures that I am giving in this particular subject anyway will have a link for any other subjects. Even when you are studying other subjects, if you have any doubt, you need to come back to this subject. So keep this as a reference and a foundational course to understand any other subjects. So let us go into the details and particulars of this subject in detail. So let us see this subject, electrical circuits or network analysis. As already said, in some engineering branches, particularly in EEE, it is called electrical circuits. In ECE, it is called network analysis. Again, in instrumentation, it is called electrical circuits. So whatever the name it is basically dealing with electrical components. So it is called electrical circuits or network analysis. What books we study? Because earlier, at least 20 years back, GATE, the brochure used to have textbooks, but now they are not giving what books to read. So that's why I need to introduce what are the books we need to study. So these are the 3 books that you have to study. For example, the first book is Network Analysis by Van Valkenburg. This is the foremost and oldest book internationally valid. And the second book is Basic Circuit Analyzer by Hayton Kimmerly. This book is also equivalent to this, because whenever we talk about books, some people may take help of the other books, but these two are parallelly written. So they have some exclusive ideas. They don't copy from each other. That's why they are unique books. You can study the second book. The third book is Electric Circuits by Sam series. The author is Syed Nasir. Why I have chosen this book is for students to understand the problems and solutions for this network analysis by Van Valkenburg. This is very good. This third book, Sam series, is indirectly acting as solution manual for Van Valkenburg. Most of the problems has been solved in this way, but with some new techniques which I will be dealing. What are the new techniques, the ideas that he gave? One thing is important here, whenever you're referring some books for networks particularly, you need to know one serious matter. Any textbook that does not deal with dependent source, don't read them. You will literally fail, utterly fail in the exam. Even for BTech, it's not good. Any book that is written without dependent sources or AC source in every topic, they are meant for diploma. At the most, they can read that books for ESET. But coming to BTech and GATE exam, we need to read books with a dependent source and books that deal AC right from the beginning. As I go along the problems, you will understand how they are starting right from the beginning. AC analysis is covered. Unfortunately, some books are dealing AC analysis only in the last topic of AC analysis. That doesn't work here. Therefore, my simple suggestion is go for any textbook dealing with dependent source and also AC right from the beginning. I don't want to mention what books not to read, but I only want to mention what books to read, because it's not good for me to say what books not to read. But these two books are internationally accepted, particularly Hayton Kimmerly. In that book, you have something called drill problems. And the drill problems are really very good for a student to really do. Why? Because after every section, he deals with the drill problems. And most of the drill problems are already coming in the examination. So be careful with the drill problems. Before you really go for the next section, you need to study and work out by yourself this style. This is the only unique style by Hayton Kimmerly. If you see, the same Hayton Kimmerly has written a book on EM theory. His style is the same. Therefore, please go through the problems, the drill problems at the end of each section, and at the end of the total chapter, then you can go for exercise problems. But if you go to exercise problems directly without drill problems, you neither do the exercise problems nor even understand what you call the next portion of the subject. That's why he has very choosingly, he has made a very good attempt. Unique style you can follow about this Hayton Kimmerly. And coming to Sam series, he has Syed Nasir has given a lot of problems, and he has solved almost all the problems of these two textbooks, and he has put out internationally what are the standard problems. Remember one thing, whenever you go for GATE exam or competitive exams including IES, you always worry about the question papers. That's a very good thing. But it's a great thing to know from where the questions are coming. That's really great. If a student can understand from where the questions are coming, that is greater than solving the existing or previous question papers. Even a senior student can do it. You don't need a teacher for solving the previous question papers. That's why if you solve previous question papers even for 100, maybe at one problem will come and you will be in trouble. But if you see these textbooks from which they are giving the problems, it is very surprising to know some or at least 50% of the problems are directly taken from the standard books. And people are thinking that they are being formulated so difficultly because they do not understand what books they are studying. So the books from which they are taking is greater than problems that you give. Problem formulation is greater than problem solving. I am not discouraging problem solving. I am also going through the problems now by the previous question papers, but I am only encouraging to say problem formulation is more important than problem solving. So this is about introduction of the books that you need to follow. Very simple. I never give for any subject more than 3 books. At the same time, I never give any subject more than 5 to 6 topics. And that's how any competitive exam you can easily do it. So let's go for the major topics in this subject. The major topics are: first, introduction to the circuit analysis. We need to introduce the subject and what are the elements in this, and how do they behave physically, how do they behave electrically. So normally people concentrate on electrical behavior, but we can also see physical behavior, how the components are behaving. So that's why I'll be introducing the circuit analysis or elements in the circuit analysis. Secondly, general analysis techniques. This is a name that I have given for the past 20 years. It's not there anywhere. This name I have given, or this title I have given, because this title is called, it is so general. This technique you can analyze any technique for any circuit. That's very nice. That's why I named it as general analysis. For example, I have given here KVL and KCL. This can be used for any circuit. There is no conditions laid. Therefore, I have no other name than giving this great name called circuit general analysis techniques. Then secondly, mesh and nodal. Thirdly, tie set and cut set. You know why I have written like this? KVL becomes mesh and KVL becomes tie set. KCL, Kirchhoff's law, Kirchhoff's current law, Kirchhoff's voltage law. This becomes nodal, and same KCL becomes cut set. And this is the link I have brought in this idea. So therefore, the very interesting to know, any technique can be applied for any circuit. That's why I named it as general analysis technique. Now coming to this, if it is general, why should we have three? The first, KVL and KCL, is for 1 and 2 variables. If the number of variables increase, go for mesh and nodal. If the number of variables are much more, go for tie set and cut set. So that's why this is how I have brought this link between these three techniques. And most of the competitive exams, particularly objective exams, the questions will come from KVL and KCL. Because mesh and nodal, they cannot ask such a big questions. They can be solved simply by KVL and KCL. If a student doesn't have the experience, he will be wasting his time in mesh and nodal. But the same question, what the student is doing in mesh and nodal, we can do it in KVL and KCL, do it fast. Because remember, maximum marks for each question is 2 marks. And 2 marks in a competitive exam, the speed is 2 marks is 2 minutes. So I said 2M, 2M. So remember always my slogan, 1:1. 1 M is for marks, another M is for minutes. And if anything is taking more than 1 minute, try for 2 minutes. After that, leave it. Don't struggle with that. Don't meddle with that. So this is my second topic. I have titled it. Though people give different title, this is my title for you. So general analysis techniques. Let me take the third technique. I have named it as specific analysis technique. Now this title actually came because one day I was doing theorems. I was solving problems on theorem, and one student came up and said, "Sir, you are doing problems on theorems. Then why are you using mesh analysis there?" And by that they have misunderstood, saying theorems means we should solve only theorems, we should not use general. General analysis techniques will be used everywhere, including here. So when you talk about general analysis techniques, they can be applied anywhere. The only thing is, therefore, this specific analysis techniques, what I said was, why I called it as, the idea is, this specific analysis technique is for specific circuit. You can't use everywhere. In other words, they have some conditions and constraints by which the theorem has to be used. So for example, when you are using a superposition theorem, same thing cannot be used in Thevenin's theorem. So each condition is different. That's why I tried my level best to put this title, specific analysis technique. It is so specific, they can't be used everywhere, but they are used specially for special purpose. Similarly, star delta transformation. Thirdly, source transformation. Star delta means a star network can be converted into delta network. Source transformation means voltage source can be converted into current source. By using these techniques, very specifically, you can solve some specific problems. So that's why I named these three things coming under one technique. But remember, whether it is general analysis technique or specific analysis technique, they don't have applications in themselves. They are used in applications because they are the tools. They are not the applications in that. So don't think these are the applications as such. In every subject, particularly in BTech, because in BTech every subject been introduced. That's why in BTech, first two topics will be generally tools will be applied for that subject. Only then next topics will be for applications. That's why the first topic, first we study general analysis technique, then we go to specific analysis technique, then I will take you to time response. If the input, if we give non-sinusoidal, we call it as time response. This in particularly, but in this subject networks we call transients analysis. Why transients? Because it is changing with time. So when you say transient analysis, we mean it is changing with time. So that's why you can call it as a time response in general. Particularly to this subject, you can call it as transient analysis. But remember, this is for non-sinusoidal input. You can, even if you give sinusoidal input with switch, it becomes automatically non-sinusoidal. Therefore, this is also comes under. So whether it is a sine or non-sine given, because you are putting the switch, and it is called transient analysis. This becomes a very crucial thing for electrical and electronics engineers, because the switching is linked here. Switching speed is linked here. How fast you can make the switching is linked to this topic. That's why nowadays everybody is worried about speed of the computer, speed of any system working, and they are going to be discussed under this topic called time response. The fifth topic we can talk is an frequency response. That means purely sinusoidal input you are giving. It's called frequency response without switch. And the other title that you can give is steady state, because there is no transient involved in this portion. There is straight away steady state it goes to. And what are the topics or why we study here? For example, resonant circuits we study. The resonant circuit that we are going to study is if it is used in amplifier, we call it as a tuned amplifier. That's why if you are good in transient analysis, it will automatically take you to pulse circuits. If you are good in frequency response or the steady state analysis, you can really enjoy analog circuits. So electrical circuits just with electronic device become electronic circuits. So enjoy electrical circuits, then you can comfortably go through what you call electronic circuits. So that is the link of the subject. Therefore, be careful here. Without this, nobody should really go there. And remember, this is the link between analog and circuits. Okay. Then, when you really study analog circuits, you will have what you call something called H parameter model. I'm talking about electronics. When you take a transistor, when you take any active device, if you draw the equivalent circuit, you will have dependent source. That's why I told you, don't attempt topics without dependent source. In the network theory itself, I will be dealing with dependent sources after few time. When you go to analog circuits, that dependent source is nothing but active device. So if you study electrical circuits without active device, you cannot study electronic circuits. That's why very interestingly, without your knowledge, without your feeling difficulty, we will be introducing dependent sources here, and that dependent source is going to be what you call electronic device later. But one important thing, the main difference between electrical and electronics is, though both are circuits, we call them as electrical circuits, electronic circuits. The whole meaning is, for active devices, Ohm's law is not valid. And we need to be very careful when you are using such words. I am going to talk in the lecture. Let me go to the last but one topic, that's called two-port analysis. Two-port analysis became so important. For example, take a transformer, is a two-port network. Take a transmission line, it's a two-port network. Take a transistor, it's a two-port network. Therefore, most of the electrical and electronic goods are working on two ports. So input port, output port, how to analyze them. And particularly in the two-port networks, there is something called ABCD parameters that's going to be directly used in transmission line. In fact, that parameters are called transmission line parameters. the very reason that been used in transmission lines. Similarly, if you study H parameters here, that's going to be directly used in transistor. Therefore, be careful when you enjoy this subject, then you can coolly study electronic circuits. Electronic circuits, after all, there is nothing if you are very good in this. Only thing is that you should know a little bit of characteristics of device. Except that, or but for that, there is nothing difficulty if you are good in this subject. And last and seventh topic, introduction to network synthesis. Actually, network analysis is our main subject. Synthesis is not required. Synthesis is another subject, but only introduction will be dealt here, because in some of the public sector exams, in GATE also little bit is required, and that I will be introducing introduction to synthesis, but not the total synthesis. That's why I titled as introduction, because in IES this subject is there. For EC and EEE in IES, the total subject is there. Just like you spent most of the time in network analysis, you should as well study that much in network synthesis. So I'll be just giving an introduction or a taste of it, so that much is sufficient for GATE and public sector, and that will be an introduction to IES, but another subject will be done. So these are the 7 major topics which I have kept in for my purpose and for your purpose, for you to understand and follow, because too many things is not good. That's why I made a total subject into 7 parts, including introduction.